what was your role during the investigation, and what got you interested in being involved with the research?
Okay, so I was mainly involved in the microscopy side, so we were interested in where the site of action of this metformin drug, and we thought it might be in the mitochondria. So in order to prove that, obviously you then have to sort of look for localization of the mitochondria, and we used a reporter, a copper sensitive reporter, which showed the levels of mitochondrial copper.
Okay.
So how was the experiment carried out in order to fully understand how copper binding to metformin inhibited complex 1, resulting in increased AMPK sensitive signal?
Well, most of those experiments were done in Graham Reena's lab, and they were basically biochemical assays. So I was mainly involved in the microscopy side. So we were looking at, as I said, copper levels in the cell. And this reporter is rather like a calcium reporter, so it changes its fluorescence characteristics depending on how much copper it binds. So those two questions really: whether the copper levels changed in the cell in response to metformin administration, but also where that was happening, as I said earlier, whether it was happening in the mitochondria. So, because that's where we expected, where we would have expected the metformin to act.
How was the pi electron ring delocalization significant to the binding effects of metformin?
Well, as I understand it, I think that the interaction, the way in which metformin works is it's able to build a very strong affinity with copper, and is able then to pull copper off proteins, and it takes like 2 metformin molecules to form this ring structure, which actually is able to pull off the copper. So it's a very high affinity for copper. So that's very different to quite different to what the mechanism that people thought that metformin was working through.
So what was the experimental procedure for the separate experiment involving pioglitazone?
As I remember, I think the experimental procedures were pretty much the same as far as the microscopy was concerned. I mean, basically what you do is you take the cells and you load them with the copper reporter, and then you wash out the excess. It's a membrane permeable compound, so it loads into the cells, and it's a fluorescent molecule that becomes fluorescent when it loses fluorescence when it's in the presence of free copper, but once copper is lost or sequestered, then it becomes more fluorescent. So you load that into the cell, and then you administer the particular drug or compound that you're interested in, whether it's metformin or any of the other compounds that we tested. Some of them were simply positive controls that we knew would have an effect on copper. So we had to put some positive controls actually to prove that what the mechanism that metformin was working through. So essentially we had the compound, and then you take the cells, put them live in under a microscope, keeping them at 37 degrees and in 5% CO2 as they would be in the incubator, and then you could just image them fluorescently using fluorescence microscope to see the levels of copper in the cells through the reporter.
What do these results tell us about metformin's effect on type 2 diabetes, and are there any side effects?
Well, what it tells us, I think, is that metformin is not working through the mechanisms that were originally thought, or at least it's not solely working through those mechanisms. So what it gives us is an opportunity to try to develop new compounds which might be based on metformin, which may, for instance, have a better copper sequestering ability than perhaps metformin. So now we understand at least slightly better the mechanism by which metformin works. It allows us then to take metformin as a lead compound and design other drugs around that compound to get a better, more efficient drugs. Maybe, as you say, drugs with a less side effects, or the side effects of metformin are not so serious as far as I'm concerned.
So what results from the experiments can be further used in order to help with the treatment of type 2 diabetes?
Well, essentially, that's what we'd hope to do. I mean, we'd hope to demonstrate that we can understand fully the mechanism, and we don't actually have, we haven't got every nut and bolt in place in terms of the mechanism of action of metformin. It's only a preliminary publication. So we hope we get more idea of what effect it has on the mitochondria of the cells, whether it actually affects their dynamics or their positioning or their fission and movement in the cells, and then. We then have a sort of bioassay in which we can test other compounds. So we can design other compounds, or chemists can design other compounds based around metformin, which may have a much better activity, and we can test those in a sort of an in vitro bioassay on cells, which then obviously gives us some clues to how much better they're working. Then we can develop those in the future into drugs which would be used in patients.
Okay. And how can this study be used to further understand the effects of other drugs and their metal binding properties?
Well, I mean, these indicate, these fluorescence indicators, there are other indicators around for other metals, and so you could potentially look at other compounds using exactly the same type of assay. So you could actually use sensors for, say, zinc or for lead or any particular metal that you're interested in, and then you could then test other drugs and see whether they were working through the similar mechanism of action.
And for other diseases as well, like cardiovascular diseases and
Yeah, I mean, if that's where the way that some of the other drugs are working, I mean, there are drugs related to metformin which might be working, might be working through exactly the same mechanism, which maybe not through sequestering copper, but maybe sequestering other elements which are necessary in, say, necessary to the cell. Okay.
Finally, just a brief account of the procedure that took place during the investigation, just so we have a bit more.
Well, as I said earlier, we were basically the microscopy side involved taking cells alive and adding the tracer compound to them, the copper sensitive compound, and that's quite important to get the right amount into the cell because they can affect the cell. They can be a lot of these compounds can be quite toxic, so it's a matter of titrating the amount that you put into the cell. You wash away the excess, and then you titrate in the drug at different concentrations and look to see what effects you have. And then you can basically, on the fluorescence microscope, you can record the cells live since they're in a chamber which keeps them happy and for 37 degrees and so on. You can actually look at the cells live. So potentially, although we didn't put much in the paper, you could actually look not only at where in the cell the copper sequestration was occurring, but you can also look at what effect that might have on the mitochondria. Okay.
yeah.